Hey everyone, and welcome back to the channel. Today, we're diving into the fascinating world of AI in healthcare, specifically looking at how an AI could help classify cancer stages. First up, we have the behavioral rules. These are the AI's core instructions, how it fundamentally operates. They tell the AI how to do its job. This includes things like how to grab and combine all that patient data, imaging reports, lab results, doctor's notes, everything. Knowing when it doesn't have enough information and needs to dig deeper. How to present the final cancer stage in a clear way, and show why it came to that conclusion. If the tumor is small and there's no lymph node spread and no spread to distant parts of the body, then it's stage I. If the tumor is large or lymph nodes are involved, then it's at least stage 2. If it has spread to distant organs, then it's stage 4. See? It's taking medical knowledge and putting it into a clear, rule-based format. But wait, those production rules rely on facts like tumor size is small or lymph nodes are involved. How does the AI get those facts from raw data like measurements on a scan or words in a pathology report? That's where rules for deriving higher-level facts come in. These rules translate the raw, low-level data into the higher-level facts needed for the staging logic. So, a rule might say, if the imaging report measures the tumor at 55 mm and 55 mm is greater than 50 mm, then the tumor size is greater than 5 cm. Or, if the pathology report says positive for malignancy in lymph nodes, then lymph nodes are involved. They bridge the gap between the raw data and the staging rules. Now, writing a separate rule for every single possibility can get messy. That's where rules with variables become super useful. They make the rule set more flexible and manageable. You could have a rule like, if the tumor site is somewhere specific, we'll call it location, and the tumor size at that location is greater than a certain threshold, then the tumor at location is large. The cool thing is, the threshold value could be different depending on where the tumor is located in the body, all within that one rule structure. Medical data isn't always perfectly clear-cut. Sometimes descriptions are vague, or there's uncertainty. This is where uncertainty and fuzzy rules are important. Rules can have ways to handle confidence levels. Like, if finding X is present with a certainty above 80%, then finding X is likely present. Getting more advanced, we have meta-rules. These are essentially rules about rules. They control how other rules are used. A meta-rule could say, always check for stage 4 criteria before checking for stage I. This helps prioritize the rule evaluation process. They can also help resolve conflicts if multiple rules seem to apply at once. Or dictate the order in which the AI should look at different data sources, maybe always check the pathology report for lymph node status before the imaging report. To ensure accuracy and reliability, rules for verification are crucial. These rules help the AI check its own work or look for inconsistencies in the data. A simple verification rule could be, if the imaging report says no metastasis, but the pathology report says metastasis is present, then flag this case for a human doctor to review. And finally, in a critical field like healthcare, guardrail rules are absolutely essential. These are safety rules, acting as safeguards to ensure the AI behaves ethically and safely.